I'd like to talk about wireless networks. A wireless network is literally a network without wires. We'll still run Ethernet. The Ethernet data will be sent over radio waves from one antenna to another antenna, not requiring any physical cable between the two devices. Some advantages of wireless networks: they can be easier to set up in the sense that we don't have to run cables all over our home or office. If you're talking about a small network of just one or two machines, running cable may not be that much of an effort. But when you get into 20, 30, 40 machines, and you'd like them to access the network from multiple locations, that can be a significant effort in running all of that cable. With a wireless network, no need to run any cable. A wireless network offers us some flexibility. If we have a PC in a certain location and we decide we would like to move it to a different room, you don't have to run a new cable. You can probably just pick up that PC and move it and pick up the wireless signal in the new room. Some disadvantages of wireless networks: most wireless technologies are a little slower than wired technologies. However, wireless has come a long way recently, and the speeds that are common now are typically plenty fast enough for most needs. Wireless networks are a little more inclined to interference, so electrical impulses can interfere with wired connections, but they're more likely to interfere with wireless connections. You may have trouble getting a good wireless signal in a room with a microwave oven. Also, some cordless phone systems can cause interference with a wireless network. And also, our wireless network is going to require more security. It is possible people will intercept these wireless signals, and so in order to protect our data, we will need to go through more efforts for security. We'll talk about that more in one of our upcoming sections. Wireless devices follow different standards. Ideally, when two devices attempt to communicate with each other, they need to follow the same standard. Communication will be much smoother. Most of the standards in place right now are related to a 1997 standard issued by the Institute of Electrical and Electronics Engineers called 802.11. After they initially issued this in 1997, they came back and revised the standard and called it 802.11a. Then they made another revision called 802.11b. They then made another revision called 802.11c, etc., etc. Each of these standards allowed for new equipment to be created that was either faster or more reliable or both. Some of the standards became very popular, like 802.11b. There was lots of devices on the market that followed that standard. Some of the standards never really became popular at all. 802.11c did not become very popular. Very few devices ever made it to the market. They have actually gone through the entire alphabet, and they did in 802.11z, and then they started over. So after that, it was 802.11aa, 802.11ab, and 802.11ac. For the foreseeable future, we will continue to have new standards published, and therefore new devices on the market, and it will be a constant challenge to make sure our new devices are compatible with our old devices. But again, each of these standards provides higher reliability and higher speeds. The common devices on the market right now center around 802.11g, 802.11n, and 802.11ac. The maximum speed we can expect from 802.11n is theoretically 600 megabits per second, which would be 10 times faster than G. Realistically, a number of devices on the market that implement 802.11n are not actually at the 600 megabit threshold, but they are a good bit faster than G. And then also the 802.11ac, which tops out at 1,000 megabits per second. Some of these devices are backward compatible with others, some are not. We commonly see a vendor list multiple standards because one device can implement as many standards as it wants to. So you might commonly see a device on the market right now that would be labeled 802.11b/g/n, which means this device follows the standards of B, G, and N. It should be able to communicate fully with any device that follows any one of those standards. However, if you're using an older device, you might get a slower speed. So my 802.11bgn device, when it communicates with a G device, it would have to slow down to 54 megabits per second. But when it communicates with an N device, it would be able to ratchet up to 600 megabits per second. So whenever we have two devices communicating on different standards, the best speed we're going to get is the slower of the two speeds. Before making a large investment into devices, you want to make sure it is compatible with existing devices that you have. You'll need to check with individual manufacturers, but in general, N is backward compatible with G, and G is backward compatible with B. But again, the documentation of any product should be clear about what it's compatible with and possibly what it's not compatible with.